Alright, picking up where we left off with particle motion, here's the first example. It says, the figure above shows the graph of the velocity of a moving object as a function of time. At which of the marked points is the speed the greatest? So again, a couple things you want to pay attention to is that this is a graph of velocity, and we talked about in class how velocity and speed are related because speed is the absolute value of velocity. So essentially, when you're looking at a graph, if you have this piece here that is negative, if you can think of the absolute value, that would just be a reflection of that piece above the graph. So it kind of looks like, I know it's not perfect, but something like that, where this would be point D, and this would be point E on the speed graph. So this purple function is the speed graph because it's the absolute value of velocity. So if we go back and read the question one more time, at which of the marked points is the speed the greatest? It would be wherever the speed has its highest point, which now that we've drawn the absolute value function, D is the highest point on the graph. So therefore D is the greatest speed of any of these points. In our next question, it says a particle moves along the x-axis so that its position at time t is given by, and it gives us a formula for that. For what value of t is the velocity of the particle 0? So first of all, this is position. To find the velocity, we're going to find the derivative. So the derivative of position, v prime, or just v of t, is 2t minus 6. And again, that's the derivative of this position function right up here. So this is the velocity, and they want to know what t value makes this velocity function equal 0. So if we solve for t, that would be 2t equals 6 divided by 2, and we get that t is equal to 3. So C is the correct answer. 3 makes the velocity equal 0. Next question. A particle moves along the x-axis so that at time t greater than or equal to 0, its position function is given by, and they give us a cubic function this time for position. It says at what time t is the particle at rest. So remember that a particle is not moving, or in other words, it is at rest whenever the velocity is equal to 0. So again, this is asking us essentially the same question, maybe in a different way. So we have to find the velocity function. V of t equals the derivative, which is 6t squared minus 42t plus 72. And if I want to know where the particle is at rest, I want to know when it's not moving. Or in other words, I want to know when the velocity is equal to 0. And so to make this a little bit easier to solve, I can divide both sides by 6 to get rid of that GCF. If I do that, 6 divided by 6 is 1, so this is 1t squared. Negative 42 divided by 6 is negative 7t. And then 72 divided by 6 is 12, equals 0. If I factor that, I get t minus 3 and t minus 4 equals 0. Therefore, the two t values where the velocity is 0, or in other words, the two t values where the particle is at rest, would be t equals 3 and t equals 4. Our next question says a particle moves along the x-axis with its position at time t given by that function where a and b are constants. For which of the following values of t is the particle at rest? Now again, they're giving us the same problem. This time, though, instead of giving us a polynomial function with constants already given in the equation, they're leaving the constants as a and b, and it's our job to go ahead at this point and find the derivative of that and set it equal to 0. So you could multiply this out, t minus a times t minus b, if you wanted to, and then take its derivative that way. So I think I'm going to do that rather than using the product rule, because if we take the derivative right now the way that it is currently written, we would have to use the product rule since it's a function of t times another function of t. So instead I think I'm going to multiply it out. So if I do that, I get that x of t is equal to, if I multiply first, I get t squared. If I multiply outside, I get negative bt. If I multiply inside, I get negative at. And if I multiply last, I get a positive ab. So the derivative of this, the velocity function, or in other words, where the particle is at rest, would be 2t minus b minus a. And I want to know where that equals 0, because the velocity function equaling 0 is where the particle is at rest. So I just want to solve for t. The b and the a are both constants, so I can add those to the other side, b plus a over here. And then if I divide everything by 2, I get that t equals b plus a divided by 2. And that is answer choice B. Written a little differently, but equivalent nonetheless. Next question. This one does require a calculator, and unfortunately I do not have my graphing calculator with me. So I am going to do it on Desmos just to get an answer so you guys can check your work. But obviously I want you to do it on your graphing calculator so you can get practice using that, because you will not be allowed to use Desmos on any of my tests or the AP test. You will have to use your graphing calculator when it comes to one of our tests. So I'm going to do it on Desmos now to get an answer, and then if you have questions about how to do it on the graphing calculator, please make sure to come and ask me so that I can teach you how to do it the right way on a graphing calculator as well. It says a particle moves along a straight line with velocity given by v of t equals 7 minus 1.01 to the power of negative t squared at time t greater than or equal to 0. What is the acceleration of the particle at time t equals 3? So while I'm doing this on my computer, I'll kind of walk you guys through what you would do on your computer. So let me open up Desmos really quick. So on your computer, you're going to go into the y equals screen, and you're going to enter this equation for y equals. So 7 minus 1.01 to the negative t squared. 7 minus 1.01 to the power of negative t squared. Oops, let's use x on Desmos, and you'll use x in your graphing calculator as well. Let me just make sure I type that in correctly. 7 minus 1.01 negative t squared. Okay, perfect. And I'm going to name this function f of x equals. Perfect. So from here, it says, what is the acceleration of the particle at time t equals 3? So we're given the velocity function. The acceleration is the derivative of the velocity function. And then we're going to evaluate that derivative at 3. Now on your graphing calculator, you're going to go ahead and go back to the home screen after you've entered in the velocity function for y1. You're going to go back to the home screen and go to Math 8. And Math 8, remember, is n-deriv. When you pull up Math 8, you'll be able to recall the y1 function. You'll be able to insert that x is the important variable, and you'll be able to insert 3 as the value that we're trying to evaluate the derivative at. And by doing that, once you put on all those things, it should give you one of these answers. Now, I'll do it on Desmos just to make sure we get an answer that you can check. But again, please make sure you're doing this on your graphing calculator. So on Desmos, we can actually just type in f prime of 3, because f prime of 3 is the derivative of f of x, and I evaluated it at 3, and it says the answer is 0.054, or in other words, that rounds to 0.055. Let's see if that's one of our answer choices. 0.055. There it is. So the correct answer choice for this one is answer choice B. Again, please make sure that you are able to get that answer on your graphing calculator, not using Desmos. For our next question, I think it's another calculator one. It is. So again, I will encourage you to please, please, please use your graphing calculator for this to make sure you get an answer, but I will walk us through it on Desmos. A particle moves along the x-axis so that at any time greater than 0, its velocity is given by, and they give us this function. What is the acceleration of the particle at time t equals 4? Literally a copy of the question we just did, but they've changed our equation on us. So I'm going to go ahead and type this into Desmos while you guys are typing it into your graphing calculators. So 3 plus 4.1... 3 plus 4.1 times cosine of 0.9t, cosine of 0.9t. Oops, and again, Desmos likes x's, just like your calculator does. Alright, let me review that to make sure it looks correct. We have 3 plus 4.1, 3 plus 4.1 cosine of 0.9x. Perfect, cosine of 0.9x. Awesome. And we are evaluating it at t equals 4. Perfect. So here's a graph of my derivative. I'm just going to go ahead and make sure really quickly that my calculator is in the correct mode, that it's in radians. Make sure your calculator is also in radians. We don't want it in degrees. And then on your calculator, you're going to go back to the home screen after you have that typed in for y1. You're going to go to Math 8 for n-deriv. Type in the important variable to be x. Recall the y1 function that you typed in. And then evaluate at 4. And I will do that here on Desmos for us as well. I got 1.632 0.629, which rounds to 1.633. 1.633 is answer choice C. Again, I cannot stress hard enough how important it is that you know how to do this on your graphing calculator. So I know that Desmos makes it look super easy, but I need you to be able to do it there. So again, if you're having trouble figuring out how to get these answers on your graphing calculator, exact to 3 decimal places, you're not allowed to just get it close. It has to be an exact answer to 3 decimal places. Then please make sure that you come ask me so I can help you with that. All right, perfect. This last one I don't think is a calculator question, so we don't have to worry about Desmos on this one. It says the maximum acceleration attained on the interval from 0 to 3 by the particle whose velocity is given by that cubic function is blank. Now, this one requires a little bit more thought process. It's not as basic as the other ones, and it might not look like it does require a lot of thought process, but let's kind of talk about why it will require thought process. First of all, they're giving us the velocity function, and they're asking us for the maximum acceleration. So we need to find the acceleration function first. So a of t equals 3t squared minus 6t plus 12. All right, that's the acceleration function. Now, I hope that you are aware that the acceleration function in the form that it's written is a quadratic function. Were you aware that this is a quadratic function? So remember that a quadratic function that has a positive orientation, because the 3 is positive, a quadratic function that has a positive orientation is going to look something like this. Now, I don't know where my vertex is. It's probably not down here anyway, but wherever the vertex is, it's a positive orientation, meaning it's facing up. So the fact that they're asking us for a maximum acceleration, I'm looking for the maximum of this graph. Now, you might think to yourself, like, why would it be asking for a maximum when a parabola is facing up? It's actually giving us a minimum value, which is true. But if you look closely at the interval from 0 to 3, the fact that they're cutting off pieces of the graph, they're not using the whole thing, because the arrows obviously indicate that it goes to infinity and continues to go up forever in both directions. But because they're giving us this interval from 0 to 3, that means they're cutting off pieces of the graph, and there should be a maximum if they're cutting off pieces. So for example, they're going to stop it at 0. So instead of going all the way over here in the negative direction, they're saying, nope, why don't we stop it right here at 0? And then let's say that this is the value at 3 or something over here. So let's say they stopped it right here. So this would be from 0 to 3. So I think it's going to be important to do a couple things. Number one, we should probably just find out where the vertex is just to be safe, that we know kind of a better picture of what this looks like so we have a good idea. And then let's evaluate what points these are at 0 and 3. Again, this picture could be totally wrong. So at 0 and 3, we'll evaluate where the function is to figure out which point is the highest. Because obviously, if you look at just this piece of the graph, after we cut off the ends of it, then it does have a maximum acceleration, because on a closed interval, we will have a highest point. So let's come back to the work part of it. To find where the vertex is, and I know you know how to do this using pre-calculus knowledge, but we're going to do it using calculus knowledge. To find where the vertex is, I need to know where it has a horizontal tangent line, because if I can find where it has a horizontal tangent line, then that means that it's turning, because I know the shape of a parabola and I know it'll be turning there. So I, in other words, need to know where the derivative of this function is equal to 0, because wherever the derivative of this function is equal to 0, that function will have a horizontal tangent line. So let me go ahead and take a minute, and I'm just going to erase this picture, since this was just a general sketch of what it could look like, and we're actually going to find out what it does look like now. So the derivative, a prime of t is equal to 6t minus 6. So I want to know where it has a horizontal tangent line, or in other words, where the derivative is equal to 0, because again, that would be a slope of 0, and a horizontal line has a slope of 0. If I solve for t, I get that t is equal to 6 over 6, or in other words, that t is equal to 1. All right, perfect. So we know that we have our t value at 1. You could plug it back in up here, so I can plug in my point here to figure out where the y-coordinate of the vertex would be. So if I plug in 1, I get that a of 1 is equal to 3 minus 6 plus 12. And 3 minus 6 is -3. -3 plus 12 is 9. So I know that my coordinates are at 1, 9. So 1, and then I go up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, my a value in this quadratic is 3, so I know that my quadratic is stretched by 3. So it goes out 1, up 3 on both sides, etc., etc. So it looks something like this. And remember that it stops at 0, and it stops at 3, so it's probably going to come up like this. All right, and there's 3. 1, 2, 3. Now, oh, you guys can't see it, it's reconnecting. We'll give it a minute to reconnect, see if it can help us figure it out. All right, my iPad is frozen, so let's see if it is recording while we're talking about this. So I have a parabola drawn on my screen that hopefully will come up on yours as well pretty soon. And it has an endpoint at 0 and an endpoint at t equals 3. Alright, so mine froze, and I just redrew this because this is what I wanted you guys to see. So essentially I have this piece of my parabola, and it stops at 0, and then it comes over here, down, and it stops at 3. So to look for a maximum, the maximum on this function in between 0 and 3, I think it's pretty obvious from the graph that it's going to be over here at 3, because in between 0 and 2, those 2 points are the same height, and then at 3 it's going to continue past that and continue to go up. Now, we didn't necessarily need an actual graph of this function to be able to tell that. We probably could have just known it from the fact that the vertex is not going to be a maximum, obviously, because the vertex in this case is the lowest point on the graph, since our parabola has a positive orientation. So then it must have been one of the two endpoints. And so we didn't even need to really graph it. You could have just plugged in 0 into the function and plugged in 3 into the function and figured out pretty easily which one was the highest point. Like if I plug in 0 right now, I get 0 plus 0 plus 12. So at 0, the function has a height of 12. Now the graph lends a nice way of visualizing that it's going to be higher at 3, but let's plug in 3 now and show that it actually is higher than 12. So a of 3 would be 3 times 3 squared minus 6 times 3 plus 12. So 3 times 3 squared would be 3 times 9, that's 27. 27 minus 6 times 3, that's 18, plus 12. So this is 27 minus 6, or in other words, 21. So at C, or sorry, not at C, at 3, the height of this function is 21, which means the maximum acceleration on that interval is 21 units high. All right, and that was the last one for this section.